know it's Miss D Gordon representing.
Hello everyone, this is DG Makes Math Easy. I'm Donisha Gordon, and today we will be looking at the second part of integration for our additional mathematics students. If you haven't checked out integration part 1, then you can find the link in the description below. Like and share, subscribe, and click the notification bell so that you do not miss any of our videos. As you know, keep looking to the left of your screen as there will be very important pointers as we go along. As you can see from the title, this video focuses on the definite integral. In questions that require us to apply this concept, we will see that they give us two limits. In this case, one being the lower limit and two being the upper limit. Now, we will explain as we go along when we use those. Now, the first thing you need to focus on is that we are being asked to integrate with respect to x, 1 plus x squared. And so we go right ahead and integrate. The integral of 1 will be x plus the integral of x is x squared, raise the power by 1 and divide by that same power, plus x cubed divided by 3. And inside this expression that we have, we are going to be substituting our upper and lower limits. So substituting the upper limits, we have 2 plus 2 squared over 2 plus 2 cubed over 3. And from this, we will subtract what we get when we substitute the lower limit. 1 plus 1 squared over 2 plus 1 cubed over 3. I know you can go ahead and simplify that. After you have simplified, you can choose whether you want to work out this bracket and then this one and subtract both results. Or you can go ahead and get rid of this bracket first by multiplying each term inside that bracket by a -1. If you do not know how to add fractions, especially if they have different denominators, please go ahead and also find the link to our video on addition and subtraction of fractions in the description below. So if you choose to work out this bracket first, we will get a result of 20 over 3 subtracting 11 over 6. And when you are through working this out, you should end up with 29 over 6. None of your answers look like this, but if you convert this from an improper fraction to a mixed number, then you should get 4 and 5 over 6. We will do the same for our second question. We will integrate 3x plus 4 all cubed, and that will give us 3x plus 4 raised to the 4th power over 4 multiplied by 1 over the derivative of what's inside our bracket. We will now substitute our upper limit and lower limit into 3x plus 4 raised to the 4th power over 12. Substituting 2, we get 3 times 2 plus 4, all raised to the 4th power, divided by 12, minus 3 times 0 plus 4, all raised to the 4th power, divided by 12. 3 times 2 will give us 6 plus 4, which will give us 10. 10 raised to the 4th power will give us 10,000 over 12, minus 3 times 0 is 0, plus 4, that's going to be 4, raised to the 4th power, which will give us 256 over 12. 10,000 minus 256 will be 9,744 divided by 12, and that will give us our final answer of 812. As we explored in our differentiation video, if we get a question looking like this, we can rearrange the expression to look like this. And so we do not have a fraction. And so we are integrating 5x minus 2 raised to the power of -2 with respect to x. We go ahead and we increase the power by 1. -2 plus 1 will give us -1. And then we divide by that same power. And then we know we're also supposed to multiply by 1 over the derivative of what's inside the bracket. We keep our limits -4 to -1. So this is 5x minus 2 raised to the -1 divided by -1 times 5, -5. And And we can keep our negative sign in our numerator. This we can rewrite as negative 1 over, we're moving 5x minus 2 to the negative 1 to our denominator, and so that our power will become a positive 1. And let's not forget that we have this 5 in the denominator. This can even be further simplified to negative 1 over 25x minus 10. And in this, we know that we should be substituting our limits, negative 4, negative 1. So now that we have moved the first part of our question to the left of our screen, we continue by substituting our upper limit first, negative 1 divided by 25 times negative 1 minus 10. And from that, we are going to subtract, substituting our lower limit. We have negative 1 divided by 25 times negative 4 minus 10. And then we simplify. This will give us negative 1 divided by negative 25 minus 10 minus negative 1 divided by negative 100 minus 10. This is negative 1 divided by negative 35 minus negative 1 divided by negative 110. And we are dividing two negatives, and so this should give us a positive 1 over 35 minus, we're also dividing two negatives here, which should give us positive 110. And that's our final answer. For this question, our limits are not only numbers, but we have 0 and we also have a variable z. And so we have no fear. We are just going to substitute into the integral of x squared. The integral of x squared will be x cubed over 3, and in that fraction we're going to substitute 0 and z as our limits. And this is equal to 9. Substituting z, we have z cubed over 3 minus, and we're substituting 0 cubed over 3, and this should be equal to 9. Z cubed over 3 minus 0 is equal to 9. We are solving for z, and so we need to get rid of this 3 by multiplying both sides by 3. And so we have z cubed is equal to 27. To find z, we find the cube root of both sides. And so we now have z is equal to 3. This question is pretty simple. It says if x is the definite integral of f of x using the limits a and b, and we know that a is less than c, but b is greater than c, so c is a value that is between a and b. Which of our options from a to d is true? And the only smart answer to that is c, because this simply means that I can find the integral of f of x from a to c, and then add that to the integral of f of x from c to b. Our final question is simple substitution, and it says if the integral of f of x using the limits 1 to 4 is equal to 6, then what is the integral of 4 times f of x using the same limits plus 5? What we need to remember at this point is that the integral of a constant times a function is the same as the constant times the integral of the function itself. And so we can rewrite this like that. And so this will now be 4 times, what is the value of this? They told us that is 6 plus 5. And so we have 24 plus 5, which will give us 29. That's it for our video on definite integrals. Join us in our next video where we will explore how we use the definite integral to find area under a curve. Let me know in the comments if this video was helpful for you, and don't forget to like and share with a friend. It's goodbye from DG Makes Math Easy, where we are intentional about making math new dimensional. I'm Donisha Gordon. See you in our next video.